So let's talk about a moment in time back in 2017 when a single research paper dropped and basically changed everything for AI. It introduced an idea, an architecture that is now the engine behind almost every single large language model you've ever heard of. Today, we are cracking open that paper. Attention is all you need.
I mean, just look at that title. That's not just a name, that is a statement. It's throwing down a gauntlet. At a time when AI was all about these complex, one step at a time models, these researchers came along and asked a wild question. What if you could just get rid of all that? What if you could build a world-class AI model using nothing but attention? Now, to really get why this was such a huge deal, you gotta understand how things used to be. Before this paper, the undisputed kings of language were models called recurrent neural networks, or RNNs, and they all worked in a way that seems pretty intuitive. They read a sentence, one word at a time, from left to right, in order. And right there, that's the big problem. That one word at a time approach is a massive bottleneck. You literally can't process the last word of a sentence until you've gone through every single word before it. This made training painfully slow. You couldn't really use modern GPUs to their full potential. And maybe worst of all, by the time the model got to the end of a long paragraph, it had kind of forgotten what happened at the beginning.
This slide just lays it out perfectly. On the left, you've got the old way, plodding along word by word, struggling to keep the whole context in its head. And on the right, you have this radical new idea. Forget going in order. Look at all the words at the exact same time and just let the model figure out how each word relates to every other word. This wasn't just a small step forward, it was a completely different way of thinking. All right, so let's get into the guts of it. How did they actually pull this off? The secret is a mechanism called attention. Now, attention wasn't brand new, but the way they used it was. They didn't just add it to an existing model, they decided to make it the entire show. Okay, I know that definition looks super technical, so let's forget that for a second. Imagine you're trying to understand the word it in a sentence. It is your query. You basically shout out, hey, what am I referring to? Every other word in the sentence is a key, and they each check how relevant they are to your question. Maybe the robot is super relevant, so it raises its hand high. The street, not so much. The actual meaning of those words, the robot and the street, is their value. The attention mechanism then just looks at the words with their hands raised highest and blends their values together to give it its true meaning. So to put it a little more formally, here's the process. For every single word, we generate a query. We take that query and compare it to the key of every other word in the sentence. That gives us a score. That score tells us how much of each word's value we should pay attention to. We mix it all together, and boom. You get a brand new version of your original word that is now deeply infused with the context of the entire sentence. But they didn't stop there, which is kind of awesome. They thought, why should we only look at the sentence from one point of view? So they came up with multi-head attention. They just ran the whole attention process 8 times in parallel. It's like having 8 different experts reading the sentence at the same time. One expert might be looking for grammar, another for who did what to whom, and a third might be looking at the overall vibe or meaning. It just gives the model this incredibly rich 3D understanding of the language. So you've got this powerful new tool. How do you build a machine around it? Well, you can't just plug it into the old systems. You need a whole new blueprint, one designed from the ground up for speed and parallel processing. And that's what they built. They called it the transformer. The transformer has 2 main parts, an encoder that reads the input and a decoder that writes the output. And inside each of those, you have these stacks of layers. But here's the absolute key, the innovation at the bottom of the slide. They completely threw out the old recurrent and convolutional layers that everyone had been using for years. They were just gone. Okay, wait a minute. This should raise a huge red flag for you. If you're looking at all the words at once, how in the world does the model know the difference between the dog chased the cat and the cat chased the dog? The order is everything. It completely changes the meaning. And the solution they came up with is just so clever. It's brilliant. Before the words even go into the model, they add a little piece of information to each one, a sort of mathematical fingerprint called a positional encoding. Using some smart math with sine and cosine waves, this signal tells the model exactly where each word is in the sequence. First, second, third, and so on. It gets all the benefits of knowing the order without the downside of having to process things one by one. So we have this totally new architecture, this crazy idea to use only attention, and this clever hack to handle word order. It all sounds great in theory, but did it actually work? Oh yeah. The results weren't just an improvement, they were a demolition. Just take a look at the numbers from the paper. This is for machine translation, where a higher score, called a blue score, is better. The best models in the world at the time were topping out around 26.3. The transformer comes along and just, bam, 28.4. It didn't just beat the record, it shattered it. Now you have to understand, on a benchmark this established, a jump of zero point 0.1 or zero point 0.2 is a big deal. A jump of over 2 full points? That's the kind of leap that redefines an entire field. It was basically a mic drop moment, announcing that a new king had arrived. But here is the part that made everyone's jaw hit the floor. Not only was it more accurate, it was ridiculously more efficient to train. The transformer achieved its new world record using a tiny fraction of the computing power that the previous models needed. It was better, faster, and cheaper. You just can't beat that. It was a total win across the board. So let's bring it all together. What was the fundamental reason this worked so well? Why was this self-attention approach just better than everything that came before it? This little table from the paper really tells the whole story. For an old recurrent layer, the number of steps it had to take grew with the length of the sentence. That's what that O of n means. But look at self-attention. The number of sequential operations is O of 1, constant. It doesn't matter if the sentence is 5 words long or 500 words long. It does the core computation in one shot. And that one simple fact leads to 2 absolute game-changing advantages. First, because it's not sequential, you can finally use the thousands of cores on a modern GPU to do everything at once. Massive parallelization. And second, the path for information to travel between the very first word and the very last word of a document is now one step. This completely solved that long-range memory problem that had held back AI for years. And let's be super clear, this isn't just some interesting piece of academic history. This breakthrough, the transformer architecture, is the direct foundation for everything we call generative AI today. Every time you chat with GPT or use BERT for search, you're using a direct descendant of the ideas in this single paper. It is the bedrock of the AI revolution we're all living through right now. Which brings us to a final, really exciting question. The authors even hinted at this in their conclusion. They figured this idea could work for a lot more than just text. Maybe images, audio, video. So the question for us today is, what's next? What's the next industry, the next type of data that's about to be completely reinvented? Because it's starting to look like, for a whole lot of problems, attention really is all you need.